Good evening, all. Uh, Welcome to another webinar hosted by 99X. So today we are hosting a webinar on a very trending topic, how to architect co-pilots. I mean, this is very interesting and trending topic when it comes to generative AI and modern technology adoption. So last 3 to 6 months, we have been working on this interesting technology. So I have been hands-on working on this technology in prototyping, developing and designing co-pilots for different European stakeholders. So in this session, I would like to share some of my thoughts and experience. Those who are willing to join this journey, probably those who will write co-pilots and this kind of technologies in their product in time to come. So let's get started. To set the context correct, so I'll play a video. So this will set the tone.
In the world of enterprise systems, we've come a long way from monolithic applications to client-server applications, microservices, and micro front-end UIs. With each evolution, user interfaces became more sophisticated, yet systems grew more complex. Users found themselves lost in a labyrinth of options, tasks, and menus. But with each evolution, one thing remains: complexity. We've improved user experience, but the complexity of workflows still holds us back. But let's pause and ask ourselves a crucial question. Do we really need end users to be burdened by this level of complexity? Introducing Optimaxer AI, a platform which can transform existing complex enterprise-level applications into natural language-based tasks. Let's look at how a complex workflow task like placing a sales order can be executed using the Optimaxer AI platform using just natural language command. Optimaxer AI brings in human-like AI agents who can perform complex tasks with a simple natural language command to optimize your business workflows. These customizable human-like agents are specialized in performing complex tasks, while ensuring features like personal data security, authentication, and authorization.
Yeah, I think this video, you have got a very high-level understanding of the context we are going to talk here. So forget about the platform name. So that is not why we are here. So last 6 months, we have been working on this platform. And what you have seen, a natural language-based co-pilot for sales order. That is one of the very good example what I meant by a co-pilot. So this kind of AI-driven natural language or generative AI agents that sits along with a human operator and who can assist these day-to-day operations of a software worker, and who can actually speed track or improve the efficiency of decision-making process. That is a kind of product that we can say as a co-pilot. So you probably you have seen that most of products that already are in the market, they are on this transition. So they are trying to see what is the next generation of product that which can reduce the complexities of the existing product. So when you look at the video, you can see that over the period of time, what we have done is we have made things complex. But I think this is one of the best time where you can rethink, do something completely different, and use AI to try out a complete different angle rather than trying to make typical incremental improvements. do something different and which makes your product better and bring higher level of efficiencies. So that is the whole idea behind this. And along the way, we were able to write vast collection of AI agents, which can help to prototype these kind of co-pilots. For example, we have developed certain co-pilots that actually can automate a complex API platform using a natural language. Imagine you have a, let's say, a complex ERP platform. Can you drive it using a natural language? It is a very complex task. And also we were able to do very simple things like Q&A agents, AI assistants like HR bots, HR assistants, customer support assistant. So very low end line of AI assistants which run on top of uh, generative text, and also very kind of a modern recommendation platforms, AI agents which can bring a open AI based recommendations, which will drastically change the traditional what do you call this item to item matching and the behavioral matching type of recommendation engines. So this is a complete game changer. And also some facts like extracting important information from unstructured data. So these are the kind of things that we did during the last few months. So we'll take you through how we design this kind of architecture. If you look at the core behind all of these co-pilots that we have been talking about, it's nothing other than large language models, right? So if you take for example, you can take GPT-3, GPT-4, what is behind ChatGPT, those are the kind of large language models we are talking about. And what these models are doing is mimicking something similar to brain functionality. I mean, not its exact replica of brain, but it will try to mimic most of the neural part of it using artificial neural networks. So to compare brain and this kind of model, so it's like comparing if your brain may have 100 trillion synapses, whereas these kind of GPT models have 175 billion parameters, which is kind of we are not getting closer to brain, but so at least you can come to a region where you can compare things, right? So that is what we are moving on. And the core of these models, it's one part is the long-term context of the neural network, which is the neural network. And also the other part is the attention layer of this neural network. So there are purely two ways of architecting these products. One is based on controlling attention mechanism of these neural networks that we call prompt engineering. So that is the core way of you instruct large language models. And the second way is basically you pick the underlying neural network, which is a costly operation, which require high sophisticated set of skills, tools, and process. So if you look at two different use cases, so as I mentioned, one is you basically play with your underlying neural network, and if you take other axis as prompt engineering, basically where you try to control your attention mechanism. So based on its usage, the low to high, if you rank, so the use cases are high with prompt engineering. Those are the cases where things like HR bots, then customer support assistants, so which are more to do with prompt engineering based architectures. On the other hand, you have very deep domain use cases where you need to tweak your underlying AI model or neural network to match specific deep domain use cases. If you take diagnosing a cancer on health domain. So these kind of deep domains you have to do with fine tuning. There's no way you can do it with prompt engineering. On the other hand, you can have very hybrid approach where you tweak your deep learning model as well as you use heavy use of prompt engineering. These are the cases where you, like I mentioned, driving uh, sales copilot using natural language API, Open API, driving using natural languages. That requires both combination of prompt engineering and little bit of fine tuning. So these cases are becoming more common nowadays. And with the cost of these AI models, these are becoming very common. So at level 0, so I have structured this architecture into 5 different pillars. If you take the lowest level, that means if you are interacting your architecture directly on the raw low level language large language model, there what you do is you are purely drive prompt engineering with large language model. So giving instructions, prompt engineering is the way you instruct to a large language model. So if you look at other aspects like short-term memory, long-term memory, which is available in our memory architecture, human architecture, those features are not directly available in the large language model. So when you are designing a software product to support long-term, short-term memory, short-term context, this kind of, and the execution part. I mean, language models are designed to generate text, but suppose if you want to execute some function in your backend, so you have to integrate some tooling mechanism along with the language model. Those are not directly available in the language model. So that is what we are going to discuss here. So if I take level 0 example, so if you go to platforms like Azure OpenAI services, so there what you do is with use of playgrounds, you can try out these scenarios. Of course, when you integrate these scenarios into your architecture, you have to use APIs, but I am just explaining the very raw level use cases. So easily you can integrate these practices into your platforms. So they are raw level. You are talking about getting some tasks from your language model. Those are the very primitive cases you can think of. So using a system prompt, you can set up a persona and your intention you want to achieve with your language model. And also you can, to improve your accuracy, what you are trying to achieve. So you can give some examples into these models. So this is just tweaking the attention layer, and this is not about you are fine tuning your model, right? So when you build this context, you can use LLM as a chat application. So there's a concept called chat API, OpenAI chat API. So that you can build a conversational way of working with this large language model, right? So this is a very level 0 example where you can use simple prompt engineering. And the second approach could be, it's not about chatting, but try to do some simple tasks from your large language model, like things like classifying a text, extracting some business entities from a mail or your unstructured document. Those are also very simple level, low level use cases that you can do with this large language model. In this example, you can see I am trying to extract some uh, personal information from a given paragraph. right? So if you drive this is a very good level 0 use case, right? So simply these kind of tasks you can incorporate in your products then and there. I mean, you don't have to find very complex use cases, but these are pretty straightforward. If you see such use cases, using a simple API, you can do this with a little bit of prompt engineering knowledge. You can do this, right? This is level 0. Then when it comes to level 1 of the architecture, I mentioned that these language models doesn't have a long-term or short-term memory. That means it just do something and it forget it, right? So if you look at ChatGPT, on the other hand, you can see that it preserve your knowledge within the session, right? It builds up a context, right? So that is built into the application and it is not into your language model. So if you are building level 1 architecture, so you have to have a context building uh, use cases. I mean, you have to build this short-term memory into your application, right? So you can maintain your chat history on maybe a local database. So together with your prompts, you can send your uh, context. This is a good example. I mean, as similar to before. So you have the system message where you set the context, and you also have examples which describe chat scenarios and how history works. And into the real message, while you are passing your question or your prompt, you basically pass your history, right? So you can see that every request that you made for these LLMs, so you have to pass a history prompt. So if history is too long, then you have to summarize it and send the history to language model because it's stateless, right? So he doesn't understand what is your previous state is all about. So you have to build it from the client side. So this is kind of a level 1 architecture. Level 1 architecture, I spoke about how do you set the short-term memory of your language model. So if you look at long-term memory, so of course, language model have long-term context. That is your neural network. It understands the previous scope and whatever the things fed when you are training. But you don't have a long-term memory where you store your information on your systems, right? For that, you have a concept called retrieval models, where what you do is you plug some kind of storage mechanism. One of the common use case today is use of vector databases. Like if you want to store your long-term memory, so you convert your unstructured content into a embedding, which is a vectorial formation of your unstructured content. And when you do a query, so you do a vector conversion in your query. Also, you do a matchmaking process. We call it's a similarity match. So where you fetch the similarity contents from your vector database. Once you retrieve it, together with query, you send the closest information into your large language model, and then you get an answer, right? So this is how you build things like chatbot. Let's say when we had to build our HR assistant. So what we did was we convert all our content on our wikis and different policies and all these things. We converted them into a vector format so that when the user asks different questions, so we fetch this vectorized information from our vector store and then push that information after modernizing. Like you have to do certain things like removing this personal data and things like that. But then you send your data to LLM and you get a creative output from the LLM. So that is level 2, building a long-term memory. right? So these are some of the details about the vector databases. So they are you embed words, and you can match word similarity, and also you can convert them into sentence encoding, and you can match meaning, like closeness of the meanings. So that is how you build this vector technology for similarity matching. So very interesting subject. So I am not going to dive deep, but I am going to talk high level so that at least you know where to look for. And also another way you can do, like instead of vectors, you can plug your backend content system using something like Neo4j. So a graph representation. So this is another way you make semantics, right? So vector mechanism is a mathematical representation, whereas you can set up a graph kind of database for traversal and the relationships you can build. So you get a semantic on your vector, your backend long-term model, where you can query the graph and get the matches, right? So these are two different ways. I mean, even you can set up a relational database there, but then it will slow down, right? But these graph and vector technologies are pretty fast compared to relation queries, so that when you are making a natural language statement, your queries are pretty fast. That's why we pick these kind of technologies over the relational ones. Then the third level. So now, so far you have seen that we can do a lot of things with unstructured data, and it's text manipulation and summarizing, extract information. But if you want really to perform something, let's say when you are receiving a natural language statement, you want to update your backend database, or you want to call a sales API, right? So then you have to have this agent type of architecture where you have tools configured to call to your backends. So you have large collection of tools where you can talk to different backend uh, elements. It could be API, it could be SQL query, it could be anything to perform. And then you have something called a planner, like when you describe certain work to be get done. So what this planner will do is it will break down your natural language thing into an intent, and you do something called chain of thoughts, react, reasoning and act. So kind of a thinking process, and identify what are the tools that I have to invoke to get this work done. So that is what is this planning is about, right? So you have your short-term and long-term memory, which I described previously. Now you have this execution extension, which will do the planning process and thinking process, and identify what are the exact tools and what are the parameters I have to send to these tools. So that will happen in this planning, and you execute your backend, right? So now if you do this, basically your natural language instructions can perform things using your LLM. So LLM will just generate the required text and the instructions, but then these agents will drive the actions. So thoughts to action, right? I think so far the whole flow and the concept is pretty clear. So what I described up to level 3, cost-wise, I think these are very doable. I mean, these are expensive when you compare to regular application development. But when you compare to the traditional AI, the investment that you make on a traditional AI, so those are doable, right? The level 4 is more about doing a deep fine tuning on your neural network. So which is a bit out. I am not going to talk in detail about this, but this is something you can also do with very high cost and also time consuming. You need special hardware, GPUs, all these structures in place to do this job. So but this session is I didn't plan at least to talk about this. And the level 5 is more about converting your natural language into voice, and also like virtual reality, things like talking heads, where you can say if you want to automate your banking support process. So if you want to make a person who really feel like the same support center operator, so that technology is also there, right? So you can using APIs, using natural language, using voice control, you can do all these things, right? So you can integrate uh, uh, AI, virtual AI assistant, as same as how you integrate a new person to your organization. So you can bring digital trust and identity and expose your APIs to these new identities. There are many platforms which you can use for this, right? So if you look at this LangChain, OpenAI, these are very, very comprehensive platforms where you can integrate these different pieces together and perform the digital AI use cases what we have been thinking in the past. And these are real. I mean, so no more fantasy. Uh, so a bit about tools, but maybe I will just go into uh, some platform examples where I mean, you all are developers, so you will like to see them better rather than doing a conceptual presentation. That's why I brought this part also into the picture. But if you go to OpenAI Studio, this is a available service in the Asia Cloud, and there are playgrounds where you can play with this, right? So and there are very good samples, right? So whatever I spoke here, so you have working examples, simple task level working examples, but of course it will be complicated if you are to automate a complex workflow like ERP workflow using OpenAI. That's a different story, binding these pieces together. But if you go here, you can try out most of the scenarios I described here. So this is one very good place where you can try it out. And also this is open AI service. But on the other hand, there's another service called Machine Learning Studio in Asia, where you can, this prompt flow is a good place where you can automate real use cases in a designer mode. I mean, minimal coding, and you can basically drag and drop these different pieces, and you can wire up considerably complex use cases. You have LLMs to select from, so where you can select any LLM for your preference, and you have prompt. You can combine prompts. You can plan a flow of prompt rather than I'm just thinking about more complex scenarios, just not just like what you type on the chat GPT, but the chain of prompts. And also you can integrate tooling, which I mentioned, things like if you want to execute something on your backend using large language model, that you can plug it in here. And you also have very uh, readily available tools where you can do like this FICE index. For example, this is a vector store, very typical vector store, where you can convert your document and create index, vector index, and you can try out this vector matching and this Q&A bots kind of things. You can do usually LLMs are like those are not directly connected to internet, right? Suppose if you want to like it's if you take GPT-4, I think it's after 2021 October. Can't remember the exact dates, but you don't have any more information after that date, right? But if you want to combine that knowledge and what is available on the internet, this is good way, right? You can search on the you have a search API, and you can combine this LLM neural network and what is available on the internet. So you can build some hybrid use cases. And embedding, as I mentioned, if you want to convert into vector format, you have tools for that. So pretty powerful place. This is available as a preview version in the Asia. And also try out LangChain. LangChain is not a cloud service at that time, but most of these pieces, the components, are part of LangChain. So if you want to drive a complex thought chain, say if you take things like Baby AGI, Auto AGI, Auto GPT, those are very complex thought process. So you can give a simple thought into your model and let him work, let him do reasoning, search, and come up with a solution. So if you want to write a, like say, automated software for solving, let's say, advertising campaign. So this is something we have been trying out. So that you can do basically using these thought chains, complex tooling. So those are pretty interesting scenarios where we can try out. Yeah. So keep your eye and do simple exercises. I mean, that is how we also learn this journey. So we always we selected few use cases and implemented them one by one. Then I mean, that is how we have started, and that is how we have been evolved to this level. So with that, I think I will just open up the flow for questions. I mean, you can write down your questions into chat. So probably Dino will speak it out. So if you have any questions, I think this is the time to start that session. Maybe I will start with a simple question. One common question. How do you select your base model? That is one of the biggest question I had all the time in my mind when I do this, right? Because if you look at, maybe I have a slide around that. Let's see, to sure. No, but yeah, one of the question that always comes to mind. I mean, you have to be very clear on what type of task you are going to achieve, right? If it is complex solving concern, so definitely you have to go to something like uh, GPT-3 Da Vinci model, which is the highest level of intellect uh, recorded into its neural network. And also lately, there have been considering they are also going backwards. I mean, if you look at the initial models of this GPT, those are more closer to instructions. So instructions are more like commands, commands that you see in DOS prompt, commands that you in CLIs. Those are command-driven language. But what we do is a human kind of language, right? So you have a lot of verbose and also semantic into human-like language, right? So gradually, when we select this Da Vinci kind of models, so it has this human-like element into this GPT models. So there's a tendency that people actually go back and select more instruction-based models if you are to adapt something like converting your APIs into natural language. It's better to have a instruction closer language than trying to be like more like humans, right? That is obvious use case. And also there can be situations, we also like lately, maybe last 2 to 3 days, we were trying to solve some mathematical problem using LLM, which is not a good thing to do. I mean, it will do certain good statistical analysis, mathematical, but when you have very complex maths, what you have to do is give that job into a tool, right? And you automate the invocation part, right? So as I mentioned, in this architecture, we have the option of pushing that algorithms into these tools, and that mathematical modeling those parts into tools, which is really good at solving. And this chaining planning can design the how we are going to control the execution sequence of these functions, right? So that is the way to automate if you are trying to solve something mathematically, right? And in that case, you don't have to use something like Da Vinci because it's expensive. So you can lower the model, which is less expensive, but who can handle this planning kind of work, right? So then you select something different, right, which is less expensive. So these are also pretty much important architectural concerns, because finally, if you are designing a solution that that is pretty expensive to run, so that is bad architecture. So you also have to think through that, like, am I using the right model or most efficient models to what I am doing, right? Because some tools, some models are just like Swiss Army knife, right? So you can do anything, but none of them are effective, right? Some models are, if you have to code, you may use Code Llama, something like Code Llama model, right? So that is also very important part of your architecture. And also be aware of there are analytic tools you can plug into these models, and you can see the consumptions of token. And even if you go to playgrounds, so you can see how much tokens it's consumed. And even I think now you can directly translate into the dollars, right? The number format, right? Any questions? Can I please get some references where I can understand the mathematical side of uh, optimizations of language models? Right. Yeah. Uh, so yeah, so far it's mainly based on reading, Adisha. So I don't have any specific for research things. Actually, what I did was I read a lot about this baby AGI a research paper, and also attention is everything you need to know. That is another wonderful research paper where I talk about the internals of these large language models. So around this, you have 3 or 4 core research papers which explain the baby AGI part and the natural language part. Especially if you go to the documentations and use cases of this uh, LangChain documentation, they are very precisely described use cases, and they are describing about these thought chains and the React prompting, which are very special optimized prompting mechanisms for this kind of work. So those are the things actually personally I read, but I will maybe I will have, like, when we are publishing this webinar, I will have those under comment section, so you can directly refer them. So otherwise, I think you should be able to reach me through these social channels, LinkedIn, wherever you want. So even yeah, that's fine. So you can have a personal discussion what exactly you wanted to understand here, right? So I will share my knowledge and experiences on that. Any other questions? Yeah. Oh. Okay. Yes. I think since we don't have much questions, we will wrap up it from here. But just stay tuned. I mean, I think this is, I would say this is a level 1 session where I try to just to explain the overall picture. So I didn't actually dive into deep parts of this entire architecture. So right now you might understand that this is how complex this whole subject is. Probably in future, just stay tuned with 99X webinar series. So we are planning to do more of these kind of sessions. So in each session, I at least try to cover a more deeper scenarios. So I think this is a good start. At least you all understood what type of things we can do here. So in time to come, we'll organize few more sessions like this. So yeah, I hope you all learn something from this session, and just keep looking forward to have more sessions, and keep in touch. So you can reach me if you have any detailed questions. Thank you for all of your participation, and we will just wrap it up here. Thank you.